Hello, Professor Sargent here with you again. Toward the end of class, we were taking a look at this standard minimization problem. And although the author had provided the Final Simplex Tableau and was asking for us to read the solution to the dual and to the primal problems, we went through determining what the primal problem was, setting up the initial simplex tableau, and we went through 2 rounds of pivoting to arrive at the matrix that is showing at the bottom of the calculator right now. And we still have a negative in the bottom or objective row. In the far right of the first row, we have 10/19, and where that negative was in column 2, we've got 6/19. So we're going to be dividing 10/19 by 6/19. Which should just be 5/3. And it is. Let's print matrix A again, so I can do some scrolling. In row 2, we have 7/19. And in that column, that will be our pivot column, where the only negative is, we've got 8/19. So we are dividing 7/19 by 8/19. That's going to be 7/8, or as a decimal, 0.875. And in any case, that 7/8 is a proper fraction. The 5/3 is improper. So 7/8 is less than 1. 1 is less than 5/3. And so row 2 is going to be our pivot row. We want to turn that 8/19 from column 2. Column 2 is our pivot column. We want to turn that 8/19 into a 1 to begin with. I'm multiplying by its reciprocal. And that's going to be multiplied to everything in row 2 of matrix A. Convert back to fractions and then store. Updating matrix A. Then in that same column, we will multiply row 2 by negative 6/19 to make that 6/19 into a 0. Negative 6/19. We're doing this in matrix A. Then more specifically, row 2 is doing the changing. What's being changed is row 1. Convert back to fractions again. And then save, or sorry, store to update matrix A. And finally, in column 2, negative 72/19, we're going to take positive 72/19 times row 2 and add it to row 3. And I do have it stored. Okay. Say row 2 is doing the work. What's being worked on is row 3. And we do see the first column 1 0 0, second column 0 1 0, third column negative 3/4, 19/8, and 9. About half of it's good so far compared to what the author provided. 1/4, negative 1/8, and 1. -1/4, 5/8, and 5. Last two columns, 0, 0, 1. That's good. 1/4, 7/8, and 13ths. Everything matches up. Took 3 rounds of pivoting to get there, but it matches up. Okay, so remember we wanted to read the solution to both the primal and to the dual. For the dual, we have U and V with unit columns. For the dual problem, our new variables were U, V, and W. We have unit columns for U and V. So for U, we see the 1 in row 1, and reading across to the far right, we have that U would equal 1/4. Whereas we have for the V column, the 1 is in row 2. So from the 1 there, read over to the far right, V is 7/8. So U and V were basic variables. W does not have a unit column, so it's a non-basic variable, and W is equal to 0. This is producing our maximum in the dual problem of P equals 13. As for the primal problem, our original variables were X and Y. We're seeing those in these two columns right here. And the way to read the Simplex Tableau's answer to the primal problem, look all the way down to the bottom. Look all the way down to the bottom underneath X and Y, down to the objective row. See underneath the X, we see a 1. Underneath the Y, we see a 5. And that same value of 13, that's going to be our minimum for the primal problem. So again, X is 1, Y is 5, and C is 13. If you check that up here, 3 times 1 plus 2 times 5, that does give you 13. And when you plug in 1 comma 5 for X comma Y in the first constraint, that will give you 10 greater than or equal to 10. On the second constraint, that will give you 12 greater than or equal to 12. And on the third, that's going to give you 21 greater than or equal to 12. All of those are true. Hope that's helped. See you in the next class.